Hi everyone, and welcome back to the second session of IGCSE Math Preparation. My name is Irfan and I'll be talking about accuracy today. As you all know, accuracy is one of the topics which is covered in the syllabus, and if you go through past year paper question, you will see plenty of questions regarding this topic. First thing first, we're going to talk about approximation. What is approximation? Well, in many examples, we don't really need an exact numbers, and it's not even desired. So we can actually round up numbers. So this is where the approximation comes in and help us. There are a few ways we can do that. The first type, so this is approximation. The first type would be rounding. This is something that many of you might be familiar with. For example, let's say you are a reporter and you're about to report a football match, and there are about 28,632 people in the stadium, and you want to report the number of audience or the number of football fans which are in the stadium right now. And definitely you don't need to give the exact number, so you're going to round it. And which number will you round it to? Because right now it's 28,000. Let's say if you want to round it to the nearest 10,000, right? So you're at 28,000 right now, almost less than 2,000 more. You will reach to 30,000, and 8,632 less, we reach to 20,000, right? Because we've been asked to round to the nearest 10,000. So that's how we should go up: 10,000, 20, 30, 40K, and etc. So I think it would make sense. It's logical if you choose 30,000 in this case, right? So the answer is 30,000. However, if they ask you to round it to the nearest 1,000, so to the nearest 1,000, what would you do? Well, same concept. We have 28,632 here. The next 1,000 would be 29,000, and the one before that is 28,000. So it would make sense, right, for us to choose 29K or 29,000. And I can ask you the same question, but this time I'm going to change the degree of accuracy, and I ask you to round it to the nearest 100. So again, 28,632, that's our original number. The next 100 would be 28,700, right? This is 600 something. And the one before that is, of course, 600 itself. So 632 is closer to 700 or to 600? Well, the answer is, of course, 600. Am I right? So you would say 28,600. We can even keep going and make it more accurate, and let's say to the nearest 10. So this is 28,632. The next 10 would be 40, right? 28,640, and the one before that, basically the last two digits, right? So what would be the answer? Again, 32 is closer to 30, and the answer is 28,630. So you see how it goes. Rounding is quite easy. So I'm gonna come up with another number before I teach you the other method. How about this? 692, and we've been asked to round it to the nearest 10. I'm gonna take a look at 485 as well. Yeah, that's a nice question. So this one is obvious. It's more closer to 690, right? To the nearest 10. That's the question. However, 485, 5 is exactly in the middle. We have 490 above it and we have 480 below it. So what do you think we should do? Which one should I choose? Because this one is exactly 5 units away from each one. Well, in this case, you round up, right? So if it's 5, it's exactly in the middle. You choose the upper one, right? 490 in this case. And we're going to use this concept for the following methods as well. You will see what I mean. If you're dealing with number 5, that's a special number, what you need to do. So the next rounding method is the decimal places. A number can also be approximated to a given number of decimal places. And we use the notation dp for it. So this is decimal places, or in a bracket dp. So what does that mean? It's actually the number of digits that can be written after the decimal point. Take a look at this number, 49.32. So right now there are 2 digits after the decimal point. If they ask you to round this number to 1 decimal places, right? I mean 1 dp, meaning which you, well, anything before that decimal point, we leave it untouched. And right now I have only 1 space to fill up. And what would that number be? Well, you might say 3. In that case, it's a correct answer. However, how it's done, if they asking for 1 dp, you go ahead and look at the digit right next to that position. So 1 dp is here. So I'm gonna look at the second dp, or the second position. If it's less than 5, just like in this case, you ignore it, right? You ignore it and we stick to 3. But if it's 5 or more than 5, then what we're gonna do, we're gonna again ignore that number, but we're gonna add 1 unit to the digit to its left. Take a look at this example, 1.39 7.5, and they ask us to round it to 3 decimal places, or 3 dp. So meaning which I have 1 there and I have to fill the 3 position after the decimal point. However, I told you the technique. If it's 3 dp, you have to look at the 4th position, which is 5 in this case. Look at its behavior. If it's 5 or more than 5, you ignore it and then you add 1 to the digit to its left. So the final answer would be 398, right? So you have to be careful when you're dealing with 5 or a number, a digit more than 5. So now there is another question which you might ask yourself, how about zeros? How do we deal with zeros? Like in this case, 0.088, and they ask us to round to 2 dp. Well, basically it's the same thing, because 0 after this decimal point has a meaning, right? So they say 2 dp, we have to fill up these 2 gaps, but we look at the 3rd digit, which is this 8 here, and since it's more than 8, so I'm gonna, let me shift this to be okay, because I'm gonna round it. Okay, after rounding to dp, this is what we're gonna get. We're gonna get 0.0, and you ignore this and add 1 to the digit next to it, which is 9. So the final answer is 0.09. And I can do the same thing, same question, but this time for 3.0037. Well, this is interesting because if I round it to 2 dp, this is what I'm gonna get, because the digit on third position after the decimal point is less than 5, and if you ignore all the digits after that, you're gonna be left with zeros. The last method of rounding would be significant figure. So significant figures, what does that mean? So in short, that would be the SF in bracket. Take a look at this number, 43.18, right? So if I ask you which digit has the highest value, that would be a wrong answer if you say 8. If you look at all these digits separately without the position that they're in, of course, 8 has the highest value than any one of them, and 1 has the lowest value. But 8 is positioned in the hundreds. So the value of this 8 here is 0.08, and the value of 4 here is not 4, but it's 40. The value of this 3 is 3, and the value of this one is 0.1. So the most significant figure is 4, and the least significant figure in contrast is 8, right? So when they ask you to round this number to 3 significant figure, for example, it means keep the most or the highest figures, the top 3, and get rid of anything else. So we have 4 figures here. I have to get rid of the least one and keep the other one. So I have to get rid of 8 because it has the lowest value, and keep the other 3. So the way I'm gonna do it is just, if you recall, in decimal places, I told you look at the digit next to the last digit that you want to make the changes to it. So here is 5, 8 is 5. So if it's 5 or greater than 5, so you ignore it, but then again you add 1 to the digit left, to its left. So in this case, the answer would be 43.2. But if the number was originally 43.14, after you round it to 3 significant figure, this is what you get, 43.1, right? But here we get 43.2. So basically, if they say 3 significant figure, you look at the digit which its position, it has the 4th significant figure, and look at its behavior. Is it 5 or is it less than 5? So let's take a look at an quite interesting example which involves zeros. If you look at these numbers, 0.00305. Well, the first 2 zeros, these 2 after the decimal point, well, they don't really have a value. But this 0, which is between 2 digits, it has a value. What I mean is that if they ask you to round this to 1 significant figure, right, all you need to do is, because the highest significant figure or the most significant figure here is digit 3. So these zeros, they don't have a value. And the least is not this 0, is actually this 5. So since they're looking for 1 significant figure, I have to keep this 3 and get rid of everything else that comes after it. However, you look at the behavior of the digit after that, which is this 0. And since it's less than 5, I just ignore everything else and leave these 3 untouched. But if the question was something like that, 0.00355, and they ask to round it to one significant figure, then what you would do, again, the first or the highest significant figure is 3, and the digit after that is 5. So since it's 5, when you ignore everything else, don't forget to add 1 to 3 here. So that would be the final answer, right? So 0 between two non-zero digits has a meaning in this case. So let's take a look at another one. How about 0 point, okay, 0.00973 to 2 significant figure. So the final answer would be 2 significant figures. These digits, these zeros don't have a value. So the 2 significant figures, or the top 2, would be 9 and 7. We want to keep those. And if you look at the behavior of the digit next to it, it's 3. It's less than 5, so you can just ignore it. And this would be the final answer. So I better shift this. Yeah. After you round it, you need to show the degree of accuracy in a bracket, right? So that's the final answer. And that's how you round or find an approximation. There are 3 methods: rounding, DP or decimal places, and SF or significant figures. The next topic would be appropriate approximation. So the answer is, if the question is, if they didn't mention anything in the question, so what would you do? Which method would you choose? And the most important thing, up to what degree of accuracy you would go? Well, usually they mention it in the question, but if they didn't, we go up to 3 significant figure, right? Or 1 DP, especially 1 decimal places when we're dealing with degrees. For example, an angle, you calculate an angle and you end up with like 59.32. So we usually ignore that 2. We stick to 1 DP, right? We stick to 1 DP. And 3 significant figure is appropriate, unless guys, it is mentioned otherwise in the question. So you have to always follow the questions. If not, if they didn't mention anything in IGCSE exam, you can go with these 2. So that's appropriate. And then another thing that you need to know in this chapter is the approximation, which you can find it without using calculator, right? So basically, in many scenarios, you don't need an exact value, right? You don't need an exact answer, and you want to just know roughly what is the final answer. For example, you want to calculate mentally in your mind that 25 pieces of chocolate, which each of them cost almost, let's say, let me change. Let's say this is 23 pieces of chocolate, and each one of them costs $18. And you want to know what is the final. You don't have a calculator with you, but you want to know roughly how much is that, or how much it's going to cost you. 20 pieces of chocolate, each one is $18. So it's just a matter of multiplication, but we need just a rough and approximate number. So one way would be to if you're dealing with multiplication, you can round up numbers to the, in this case, to the nearest 10, but be careful. If you increase one of them, you have to decrease the other one to basically keep the balance between them. So, and choose the numbers that are easy to work with. 18, I would make it 20, right? And this guy 23, since I have increased 18, I have to decrease this one, and I'm gonna decrease it to 20 because that's again another easy to work with. And the final answer for this would be 400, right? However, if you do the calculation, if you carry out the calculation 23 times 18 exactly with your calculator, how much you're gonna get, the final answer would be 414. And guys, this is acceptable. 400 is pretty much close to 414. So that's one way. For multiplication, I would say it's quite easy. Let me give you another example, like 0.7 times 29. Well, I think you already know what to do. I'm gonna round this to 30, and this one I'm gonna reduce it to half, because if you multiply anything by half, it's the same as dividing it by 2. And 30 divided by 2 is 15. Again, if you use your calculator, remember guys, we're looking for just a rough approximation. We're not looking for exact answer. This is what we do it mentally. But if you use a calculator and see, find the exact answer, that would be 20.3, which is, again, it's acceptable. You know, you could have reduced this to 0.6 as well. In that case, you would get 18, but it doesn't matter. Of course, this is a more suitable answer. It's closer to the exact, but still it's acceptable. So for multiplication, the only thing I want to say is that do not forget to decrease the other one if you increase one. You cannot increase both of them at the same time or decrease both of them at the same time. That would get you very far away from the exact answer. And for division, it's the other way around. So if you're dealing with division, for example, 54 divided by 17, right? What would you do? Well, let's make it more interesting. Maybe I can add a 0 here. So it makes it look scary, but in fact, 0 doesn't really have an effect on it. But this is something that you don't want to use a calculator, or you find it difficult. Well, what you can do, you can reduce both of them to a number which is easy to work with, or increase both of them. Maybe you change it to 600 and 200, and the final answer is 3, right? And if you use a calculator, I'm sure you're gonna get a very close answer to 3. So 540 divided by 170, that would be 3.17, right? This guy right here is 3.17, and that's acceptable. 3 is acceptable. So this is what we call the appropriate approximation, which you can do it mentally. And there is one more topic left, which is about upper and lower bound. All right, let's continue with the upper and lower bounds limit, which is the last subtopic of accuracy. So the question is, what is upper and lower bound limit? So take a look at these three numbers, 12.1, 12.10 and 12.100. So at first glance, they all seem to represent the same thing, right? Which is 12.1. But the difference is in their level of accuracy. So meaning which, if you take a look at the first number, which is 12.1, that is rounded to 1 dp. So maybe the original number was something like 12.13, and which after you round it to 1 dp, this is what you get, right? Or maybe it was 12.09, right? If you recall, when you want to round a number to 1 dp, you take a look at the second digit, right? In this case, it's greater than 5. And then when you ignore it, you just add 1 to the left of it, to the digit to its left, and the answer would be 12.1. And that's the number we got here. So I could go on with the list. There are almost infinitely many numbers, even, for example, 12.09572, right? This is also a number which after you round it to 1 dp, you get 12.1. So the list goes on forever, right? Infinitely many numbers. The easiest way to show all those numbers, the range of numbers, would be the number line presentation, right? So if I draw a number line here, and if the center, I label it to be 12.1. So the largest number, the question is, what is the largest number that you can actually round it to get 12.1? So that's actually quite a tough question, but the smallest one, I'm sure it would be easy. All of us would agree that it is 12.05, right? So if you round this number, you get for sure 12.1. Well, can you say the same thing if you add a 5 next to 1 and make it as the upper, like 12.15? Well, not really, because if you round this number to 1 dp, you get 12.2, right? According to the rules. However, anything close to this, if you approach it from left and you don't include this number itself, then it's acceptable. So on a number line, if I want to highlight, I would highlight everything, including 12.05. So to show that it's included, I make a solid circle here. But to show that 12.15 is excluded from my range, I use a hollow circle. So it's very important that you use a hollow circle for the upper bound, right? And this is my lower bound. And there is another way you can present this. You can use inequality, meaning which take the original number to be x, right? We don't know what x is. And you write the lower bound on the left of it and upper bound on the right. However, 12.05 is included, so I'm going to use greater than or equal symbol, and this is 12.05. For the upper bound, it is not included, so I just use the less than notation, so 12.15. So there are two ways you can show this. This is on a number line, and you should know both, because the question might ask you specifically for a particular method. And this was 12.1. How about 12.10? So the level of accuracy, it's 2 dp, right? So it means the original number could have been something like 12.102, which after you round it to 2 dp, you get 12.10, right? Again, the list could go down, but actually a wise thing to do would be to show it on a number line. So I'm going to write 12.10 right in the center, and I'm going to take a look at the third position, right, which is empty. So you're going to add a 5 there. You get 12.105, but this guy is excluded. And then you subtract, basically you add 0.005 to 12.10 to get the upper bound, and you subtract 0.005 to get the lower bound. And if you do that, you can use a calculator for it. You get 12.0. This is one. That would be 100.095, right? Yeah, when you add 5, you get 10 here. Okay, so that's the technique basically, and this guy is included, and then you highlight the whole thing. Okay, and even if you want to use inequality, so you can use x, same thing, make sure the lower bound is included, 12.095, and this is 12.105. So for the first one, let me show you how much we added. We added 0.05, right? So, okay, and the last one, the most accurate one, if I want to show it on a number line, we get, this is 12.100, and then I add, this goes up to thousands. I go up to 10,000s, which is 0.0005. I add this and subtract this to get the upper and lower bound respectively. So this would be 12.1005, my upper bound, which is not included, and lower bound, which is included, I would get 12.995, if I'm not mistaken. You can use a calculator for that. However, everything is included between. And as you can see, just to show you how accurate this number is compared to the first one, if you want to show them on the same number line, this 12.0995, where does it fall? It actually falls very, very close to 12.1, right? It's just 5,000 units away. So it's somewhere here, very, very close, and it goes all the way. And the upper bound is just you add 5,000s, right? 10,000s to this, and you get to the upper bound. So this is the comparison. Can you see the range, the green one, how accurate it is? And that's the last number. So basically, they might represent the same number, but they have different levels of accuracy, and you should take that in consideration. So this is the first thing, that you should know how to find the upper and lower bounds. And usually they come up with nearest centimeter, nearest meter, and you should know how to answer those questions as well. Let me give you an example what I mean by that. Let's talk about a continuous data, like a height, which is continuous. So let's say you measure a height of your friend and you get 167 cm, and you round it to the nearest centimeter and to the nearest centimeter, and this is the answer. So what was the basically the original number? You can't really tell, but you can tell the upper and lower limit, right? So if you round it to nearest cm, and this is what you get, so 1 cm divided by 2, and you get half cm. So add half to get the upper bound and subtract half to get the lower bound. So the upper bound would be 167.5. The lower would be 166.5, and the numbers falls or lie within this range, right? So that's an example of the nearest cm. And sometimes they say we round a number to the nearest whole number. So that's another phrase that they can use. So you shouldn't be tricked by that. For example, we have 37, and they round it to the, they have a number, we don't know what it is, but they say it is rounded to the nearest whole number, and now we have 37. Can you tell us its upper and lower bound? Well, same concept, whole number, or the integers, right? They go by unit of 1. And if you divide it by 2, you get half again. So you add half and you subtract half, you get basically 37.5 and 36.5. That would be the upper bound and lower bound, right? You can use X in the middle to show it as an inequality. So this is quite an easy questions. However, the most important part is how to deal with arithmetic operation, which involves upper and lower bound. So the four basic arithmetic operations that we have are the addition, subtraction, multiplication, and division. So I'm gonna show addition and multiplication together. On the other hand, I'm gonna show subtraction and division together. You will see in a minute why I have divided, why I grouped them together actually. Well, take a look at this arithmetic operation, 27 plus 4. And they say we rounded each one of these number to the nearest whole number, right? And now we got 27 and 4. We want to add them together. Can you tell us what is the maximum number we can get and what is the lowest number, basically the range? Well, you have to examine them individually first. 27, if it's rounded to the nearest whole number, so its upper bound could be 27.5 and its lower bound is 26.5. Right, same thing for 4. We get 3.5 as the lower bound and 4.5 as its upper bound. Now, if you want to get the maximum number or the largest number out of this addition, well, you have to take the upper bound for each number, right? So, which is 27.5 and 4.5. So that would be the upper bound of this expression, right? Because this expression, it has its upper and lower bound, right? So if you want to get its upper bound, you have to add the upper bound of each of these separate numbers together. And if you want to get the lower bound, you have to add the lower bound of each of these separate numbers as well. So that means we get 27.5. That would be 32 when I add these two together. And the lower bounds, these two guys right here, I get 30, right? That's the lower bound and upper bound of this expression, right? And so what was the technique? Basically, if they want lower bound, you add the lower bounds together, right? Lower bounds, you add the lower bounds together. If they want upper bounds, you add upper bounds together. For multiplication, however, if we were to multiply these two numbers together, right? What would we do? Well, we know each one of them, they have their own upper and lower bound. And if I ask you which of these numbers you would choose if you want to get the maximum value out of this multiplication, of course, you would go to the maximum value of 27 and 4, which is these two, that's the upper bound. And so the upper bound of this multiplication would be 27.5 times 4.5. And the lower bound, in contrast, would be, we choose the lower bound of each one of those numbers, which is 26.5 and 3.5, right? But as you can see, it's the same concept as addition. So if you want to get the lower bound, you take the lower bound of each one of those numbers and you multiply them together. For upper bound, you do the same thing and we're done. So addition and multiplication is quite easy, but for subtraction and division, it's a bit tricky. So let me change the number to 25 and 5, for example. So 25 minus 5, and then 25 divided by 5. And we've been told that these numbers are rounded to the nearest whole number. So the 25 here, it has its own upper and lower bound limit. So it lies within the range of, the range would be from 24.5 all the way to 25.5. Same thing for 5, it lies within the range of starting from 4.5 as its lowest limit all the way to 5.5. Now, this is here on the right hand side, we have the upper bounds and we have lower bounds here. So if you want to get the largest number out of this, 25 minus 5, the largest one, of course, you choose the upper limit for 25, but you choose the lowest limit for 5, because that would give you a bigger number, right? Meaning which you would say 25.5 minus 4.5. You wouldn't subtract it by 5 nor 5.5 because that wouldn't give you the largest number. The largest number right now would be 21, right? But in that case, if you have selected 5 or 5.5, it would give you 20, right? So we're looking for the largest. So I obtained the upper bound by taking so the upper bound can be calculated by taking the upper bound of the first number and then subtract the lower bound of the second number from it. And same thing for lower bound, you take the lower bound and minus by the upper bound. So if I want to find the lower bound, I would say 24.5 minus the largest or the upper limit of 5, which is 5.5, and that gives me the lower bound, which in this case would be 19, right? So it falls, this number right here, it falls between 19 and 21, right? And please make sure that you include the lower bound. So this is basically the chart that you have to follow. I'm gonna, okay, highlight it here as well. And for division, it's the same thing. Division is anything that looks like a fraction, like let's say 25 divided by 5. So if you want to get the upper bound, you take the upper bound of the numerator and divide it by the lower bound of the denominator. So I'm gonna draw, okay, write it here. For upper bound, make sure the numerator is upper bound, denominator is lower bound. And if you want to get the lower bound, the numerator should be lower bound, denominator should be upper bound. It's not really difficult to memorize this because this guy always follow this guy right here, right? So it's the same. So it would be easy for you to memorize. And let me complete this inequality. Here I have lower bound over upper bound. Now, let's replace them one by one. So 25.5 in the middle, it should be X. I shouldn't write that. And upper bound of 25 would be basically 25.5. You already know that. The lower bound of the lower bound of 5 is 4.5. So the lower bound of 25 is 24.5, and the lower bound of 5 is the upper bound of 5 is 5.5, right? So, and if you use a calculator, 25.5 divided by 4.5, you get 5.6. And for the lower bound, you get 4.4, right? 4.45, which if you round it, I round this to 1 dp. Sorry, this one should be 7 if I round it to 1 dp. So this is the upper bound, and this guy is the lower bound. So that's how you should do it for division. So addition and multiplication is quite straightforward. Subtraction and division, you have to be careful and follow this chart that I wrote for you here. Let's do a couple of practical example and see what type of question you should be expecting actually in the exam. So take a look at this question. We've been told we have a swimming pool and the capacity is given as 630 cubic meter, correct to 2 significant figure. So that's the information given to us. Now in A, they want us to calculate the lower bound and upper bound of this swimming pool. And in B, they want us to use x cube meters for the capacity, express the range of values in which x must lie as an inequality. So basically, the same thing that I've been doing, use the x for the capacity and then show the range as an inequality. So we have to fill up these two gaps basically, and that would be easy because if you know the lower and upper bound, if you obtain that in A, in B, it's just a matter of presenting them. So what is the upper bound? If this is the number and it's rounded to 2 significant figure, so look at the third significant figure, which is this guy right here, and basically this is the units, right? The value of this position is units, and you add 5 and then subtract 5 to get the upper and lower bound. So 5 minus 5, that would be 635 and 625, right? So let's say, as a practice, let's say this number was 600 to one significant figure. What would you do to get the upper and lower bound? You would add and subtract 50, guys, to this number, not 5 anymore, because this is one significant figure. And you have to look at the second significant, basically the second digit with the higher value, that the position would be here. And this position is not units anymore, it's tens, right? This is units and this is hundreds. So if you put a 5 here, its value is not 5, it's 50, right? If you put a 5 here, its value is 5. But if you put a 5 here, its value is 50. So you add and subtract 50, and you get 650 as the upper bound and 550 as the lower bound. So be very careful what the question is at. But basically, what is the level of accuracy? Always follow that. So let's get back to our question here. Let me erase all this stuff. Now we got the upper and lower bound already. It's just a matter of presenting it as an inequality. Just make sure that the reason they ask you this question is because they want to know if you forget this equality or not, or whether you add an extra equality here, which would be wrong, right? So the lower would be 625, the upper would be 635. So that was as easy. Yeah, that was quite an easy question. However, let's deal with some harder question, which involves multiplication and division. So, all right. So in this question, we've been told that the radius of a circle is given as 4 cm. So the radius of a circle is 4 cm, and then it is rounded to 2 dp. Okay, so a better presentation of this number would be 4.00, right, to 2 dp. All right, and they said express an inequality, the upper and lower bounds for A, the circumference, right? And in B, I believe it should be area, right? Yeah, the area of the circle. Okay, so the upper and lower bound for this and upper and lower bound for this. Now, if you look at the formula for each one of them, the formula for the circumference is 2 pi r, for area is pi r squared. Now, 2 is a constant number, pi is a constant, so that's not our independent variable. So that would be r, which varies, and r has upper and lower bound because it's rounded to 2 dp. So we shouldn't worry about these two. Same thing here, we shouldn't worry about pi. We can just key that in your calculator. You can press, I don't know which type of calculator you're using, but you can find that out in your calculator, and then at the end you get your answer. So first thing first, which they didn't ask us to do, but it is required if you want to solve this question, you have to find the upper and lower bound of r. So if it's rounded to 2 dp, and this is what you get, I suggest you to pause the video and try it for yourself and see if you can get the upper and lower bound of r. So remember, the technique was that if this is 2 dp, you have to look at the third digit after decimal point and make it 5. So we have 0.005 or 5 thousandths, right? And add it and subtract it from this number, which is 4. 4.00 4.00. This gives you the upper bound, this gives you the lower bound. But I'm going to write it in a form of inequality that would be easier to deal with. So the upper bound would be 4.005, right? And the lower bound would be 4. This is minus, that would be 0.95, right? And wait a minute, I'm sorry, I made a mistake. That would be 3. That would be 3.995. Yeah, that is correct. Now if you add 0.005 to this guy, you get 4. So we took care of that. Now we just have to do the calculation. 2 times pi times, if you want to get the upper, this is a matter of multiplication, right? So do you remember for multiplication, the procedure was quite easy. If you want to get the upper bound, you choose the upper bound. So I'm going to use x to represent circumference. So for upper bound, you multiply the upper bound by upper bounds. However, we have only one number here, right, that has the upper and lower bound. So the rest is constant. So I'm just going to use the upper bound of r and multiply it by 2 pi, right? So what is the upper bound of r? That is 4.005. You multiply it by pi and times 2, and you get 25. You get 25.16 rounded to 2 dp. Of course, on the screen of my calculator, I have 415,716 after that, but I exclude all of them. No need to put them here, since originally the radius was given to us up to 2 dp. I think it is fair to give our answer in 2 dp as well. For the lower one, so same thing, 2 pi times 3.995, that would be 25.10. Don't forget this 0, guys. Don't just write it to 25.1. As I told you earlier, this 0 has a meaning, so this would be wrong. Okay, forget about 25.1. And for the area, it's the same thing. It's just a matter of multiplication. However, r squared means r times r. So I have to multiply r by itself. So if r has a lower and upper limit, you have to be careful. If you want to get the upper bound, each time basically you have to choose the upper bound and multiply it by itself. So it means pi times this guy squared, right? So 4.005 squared. And the final answer would be 50.39. That's up to 2 dp. You can leave it just like that. And same thing for the lower bound. That would be 3.995 squared. So 50.14. It's actually 139, but if you want to round it to 2 dp, this is greater than 5, so 50.14 is acceptable, right? I suggest you to calculate it yourself and see what I mean. It's also important that you round the final answer to 2 dp. So that was a nice question. There is another question which is about division. So we have a cylindrical water tank, right? And the capacity of this water tank is 6,000 cubic centimeter, correct to one significant figure, okay? And then a full cup of water from the tank has a volume of, so we have a cup. The volume here would be 300 cubic centimeter. And this is correct to two significant figure, right? So they want to know what's the maximum number of full cups of water that can be drawn from the tank. So imagine this tank is full of water and they want to know what's the maximum number of cups, right, that you can actually draw from this tank. Full cup, so the cup should be full. Now, of course, this is a matter of division. If there was no upper or lower bound, there was no such thing. If you wanted to calculate how many cups can be filled, you would simply divide 6,000 by 300. Am I right? However, each one of these, they have their own upper and lower bound. So this guy, I can, maybe I use the letter A to represent the volume of the cylinder, and letter B, you can use X, it's all right, to use, to show, yeah, the volume of the cup. So this is one significant figure. And I told you, you have to look at the second significant figure, basically this position here, which is thousands, right? This is units, this is tens, this is thousands. And you put a 5 there. In this case, 500, right? You add 500 to 6,000 and you subtract 500 from 6,000 and you get 5,500 as the lower bound. So this is how you find the upper and lower bound of this number. As a practice, please find the upper and lower bound. If the original question was this, you get 6,000 if it's rounded to two significant figure, then what would be the upper and lower bound? Two significant figure, if it's 6,000, then you look at the third significant, which is here, and you put a 5 there. So the value of 5 there is 50. You add 50 and subtract 50 to get the upper and lower bound, right? So this guy right here, it make a huge difference, right? If it's 1 or 2 or 3. So you have to be careful. That's the degree of accuracy. By now, I think you should be okay. That's the first thing you need to do. The last thing would be the division. Let's continue with the cup. For the cup, yeah, this is a good example. You see, this is two significant figure. So you have to look at the third significant figure, which is this guy right here. That's a units, right? That's a 0. So you add a 5 there and you subtract 5. So basically you add 5 and you subtract 5, which gives us 305 and 295, right? So that's it. That's the upper and lower bound for the cup. And now the question is A over B. We want to know the upper bound and lower bound for A over B, right? So if you recall, if you want to get the upper bound, you should choose the upper bound for A and divide it by the lower bound of the denominator, which is B. In that case, it is 6,500 divided by 295. And for the lower bound, we divide the lower bound of the numerator by the upper bound of the denominator, which in this case, it is 5,500 divided by 305. And if you do that, you get, wait a minute, they asked for maximum, right? Sorry, this would be unnecessary. So let's forget about, but it's a good practice if you want to find that out. But the question asking for maximum numbers, not the minimum. So we want basically the answer for upper bound. Yeah, the maximum number of cups. And if you carry on, if you do this calculation, you see that the answer is 22, right? 22, and that's the correct answer, and we're done. So that was a nice question about division. And there is one more question. It's a bit tricky. So they try to confuse you. They are playing around with the words. It says we have a match which actually measures 5 cm to nearest centimeter, right? The nearest centimeter, we get 5 cm. But then they continue, we have hundreds of these matches end to end, and the measure is 5.43 meter. So we have 100 matches end to end, and this is the result when you measure their length. This is corrected to 3 significant figure, right? This number. And in A, they're asking what is the upper and lower bound for one match? One match, right? So basically this number and this number, lower and upper bound for one match. And yeah, so the thing is, majority of students, since for one match, the question already says a match measures this, right? 5 cm to the nearest cm. So immediately they say, okay, it means it must have been between 5.5 and 4.5, right? Because 1 cm divide by 2, it gives you half cm, you add it and you subtract it, and this is what you get. However, I must stop you right there. This was correct if no other information were provided. However, they continue and say we have 100 of these matches end to end line up, and then we measured them, you get 5.43 meter, corrected to 3 significant figure. And this is the data that you have to use, not the first sentence. So if you use the first sentence, that would lead you to the wrong answer. However, if you use this and the concept, knowing that if you have 100 matches and the length is 5.43 meter, right? If you want to find the measure of one of them on average, of course you divide it by, this is meter, divided by 100 to find out what is the length of one of them. And it leads to 5.43 cm. Why? Because this meter right here is 100 cm, and then 100 and 100. From the top and bottom, it's gone, and you're left with this answer. So, however, still we're not done yet. This is rounded to 3 significant figure, right? So I shouldn't divide this by 100. I should find basically the upper and lower bound of 5.43, which is 5.435 and 5.425, right? You minus 0.005 and add 0.005 to get these two numbers. And then you divide them by 100, and you get, for the upper bound, you get 4.435. This is meter, and when you divide them, the final answer would be in cm, right? So cm, and this guy would be 5.425 cm, right? So that's how you should do it. And then denominator, if you look at the denominator, it's an exact number. It's a whole number. This one doesn't have upper and lower bound. It's 100 matches, as simple as that. Don't confuse yourself and say, okay, this is a division. So my teacher taught me if I want to get the upper bound of A over B, A should be upper bound, B should be lower bound, and then go and find the upper and lower bound of 100. No, that would be wrong. Just like in previous slide, we didn't find, in the first question, we didn't find the upper bound or lower bound of 2 or pi, right? We didn't do such a thing. We assume that they're exact, and we carry on with the calculation. So same thing here. So don't bother with 100. And yeah, this is the correct answer. So don't let the first sentence fools you. So that's there to trick you. However, if it was the only information in the question, then this is the correct answer. And for B, they say, how can the limits of the length of a match be found to 2dp? So the limits, see, this is the limits of one match. So basically they asking for the same thing, but this time in 2dp. Well, it means you have to round this number to 2dp, and that's quite an easy thing to do by now. This gives you 4 point. 2dp means look at the third digit, and if it's 5 or greater than 5, you ignore it. You erase it, but don't forget to add 1 unit to the left digit, to the digit to its left, which is 4, 4. And then for the lower bound, we get 4.43, right? So this is the answer in A, but in B, same answer, but the level of accuracy is changed to 2dp. So I think that's it for today. Thank you very much and stay safe. I see you guys in future videos. Thank you.